Okay, we're looking at 6.5, which is dealing with compound inequalities using the word or. That means when you draw your graph for inequalities, you will have arrows pointing away from each other. Okay? When you graph your inequality, that's an example. It'll be arrows pointing away from each other. So we're going to do some translating verbal phrases into inequalities. We're going to look at number 1. Translate the variable phrase into an inequality, then we're going to graph the inequality. All real numbers that are less than 0 or greater than or equal to 2. Okay, what does all real numbers mean? Anybody? Nope. All real numbers. What am I going to put down? What did we do for the warm-up? X. Good, guys. X. Okay. Now we're looking, we've got 0 and we've got 2. So what number am I going to put all the way over here on the left? Why am I going to put 0 all the way on the left? Good. Because it's smaller. And then I'm going to put 2 on the right. Okay? All real numbers that are less than 0. Okay, so which way should the alligator be eating, the 0 or the X? All real numbers that are less than 0. The alligator should be eating the 0 because X has to be smaller than 0. Or greater than or equal to 2. Greater than or equal to 2. Which way should the alligator be eating? The X. And there should be underlined. So let's graph this and see what this looks like. We've got 0, and we've got 2, and it looks just like my example, strangely enough. They're pointing away from each other. Okay, so why don't you guys try, apparently it's A, on your own. All real numbers less than -1 or greater than 2. Yes, she had to go do something. She said she would. Right. It's all right. So what is the plan? Yeah. All right, ladies and gentlemen, somebody want to try this? Okay, Demetrius, what do you do?
-1.
Okay.
X.
Okay, which way is the alligator eating for the -1 and X? All real numbers less than -1. Good. And which way is it eating for the 2? Greater than 2. So it should be eating the X. Good. This is drawing funny. Okay, so when we make our inequality, got -1 and 2. Do I have open circles or closed circles over -1 and 2? Open, because neither of them are underlined. And then X is less than -1. And X is greater than 2. So we know since they're or, they point away from each other.
Will they have to do the opposite, like they will, like you'll show them the negative, like the equation or inequality right there, now put it in verbal phrase?
them do that for some of the homework, but I will look and see. I don't remember what the quiz looks like. It's been maybe 2 days off. Okay. All right, so we should move down to example 2. Okay, we've got x minus 4 is less than or equal to 3, or 2x is greater than 18. So all you have to do for these is get x for both inequalities by itself, and then you just graph it. So what do I do for the first one? I've got x minus 4 is less than or equal to 3. What do I do? Add 4. So I will get x is less than or equal to 7. Okay, what do I do for the next equation? How do I get x by itself? We've got 2x is greater than 18. What do I do? Divide both sides by 2. And I'll get x is greater than 9. Then I'm going to make my inequality. I've got 7. I've got 9. Do I have an open circle or a closed circle over 7? Closed. And x is less than 7. Or x is greater than 9. So open circle, greater than 9. You guys ready to try B on your own? Try B. Solve for x. Then graph it. All right, who wants to start? What do I do? I know Demetrius knows what she's doing. Anybody else? All right, go for it, Mr. Marks.
You subtract 4, meaning add 4 to both sides.
Good.
And then the other one, you subtract 3 from both sides.
Good. All right, now we're going to graph it. Yes. Oh, thank you. The -8, so we should get a negative. Yeah. -8. And then this should be -4 because we added 4 to both sides. Thank you. So now we're going to graph this. We've got -4 and we've got 2. Open or close circles? Open. And they should be pointing away from each other because it is an or statement. Questions, comments, concerns about that one? Okay. So for example 3, for part A, I've got 3x plus 1 is less than 4, or 2x minus 5 is greater than 7. So my first step would be to subtract 1 from each side, and I get 3x is less than 3. Divide both sides by 3, because my second step would be to get rid of multiplication and division, and I get x is less than 1. And then I have my OR. I've got 2x minus 5 is greater than 7. My first step is going to be, what do I do first? Add 5. Good. So I'm going to get 2x is greater than 12, and then my next step is 2. Divide by 2. So I get x is greater than 6. Okay. So when I graph, I've got 1 and I've got 6. I've got an open circle over 1 and open circle over 6, and they're pointing away from each other. All right. So, yes. Oh, go ahead. Yes. Okay, so we've got 2x plus 3 is less than or equal to 1, or 3x minus 5 is greater than 1. So you should be trying part B right now by yourself. All right, somebody want to try this one? What do I do first? Yes, Demetrius. I subtract 3 from both sides. And I get 2x is less than or equal to negative 2. Demetrius, what's my next step? I divide everything by 2. So I get x is less than or equal to negative 1. Good. Somebody want to try the other side? Yes, Mr. Marks? I add 5 to both sides, and I get 3x is greater than 6. Then what? On both sides, and what do I get x to be? X is greater than 2. So I draw my number line. I've got negative 1 and 2. Open or close or close? Closed over negative 1. Good, Tyler. Open over 2. And they point away from each other.
They always have to point away.
If we're talking about or, if the word in between them says and, they would point towards each other.
So it doesn't matter which way they go.
It does. In this case, it shows us perfectly. But if we had x in the middle, okay, if you had an or statement, you still know that they point away from each other. Right? If I had an answer that looked like this, x, and I had it's less than or equal to negative 1, and x is greater than 2, in that sense, you can't follow which way the arrow goes.